Welcome everybody for this the second webinar on the findings of the AMAP work on local contamination and to look into signals which are identifying local pollution compared to long-range transport. This is a joint work of many people. Many experts have been contributed to that. I will now give relatively short overview, and then Pernilla will give a more detailed case study on specific aspects associated to local sources and cleanup procedures. When it comes to the local pollution sources, it's a relatively new focus area also for the Arctic pollution, also triggered through activities looking into extended numbers of contamination and pollutants, organic pollutants in an Arctic context to a variety of previous studies. What is in generally the working platform is that we are facing, when it comes to environmental pollution assessment, an ever increasing number of contaminants. This is also illustrated through the Stockholm Convention, which have recently extended the list of priority contaminants. So from a dirty dozen from the beginning in 2001, we are now covering for the global convention, or the global regulation of persistent organic pollutants, a total list of 49 contaminants, where 33 are listed for total complete regulation. One, DDT, is under Annex B for restricted usage, and 7 are actually listed as industrial substances in Annex C. What we see today is, for the most of from a global perspective, but also in the Arctic, for the most of the earlier regulated and investigated persistent organic pollutants, we see a steady reduction, a decline of concentrations in the AMAP monitoring activities, and the reports are going back until from the early 1990s, from the establishment of AMAP until today. The new chemicals shedding a new light when it comes to providing new information when it comes to potential presence and distribution profiles in an Arctic context. Some of the new substances, as has been revealed in the first report on chemicals of emerging Arctic concern, having a clear local profile. We see that they are either emitted directly into the air or into the water phase, and have also some potential to be taken up by the local human populations. It's therefore very important for us, and it's also one of the motivation of this report to see whether we can, based upon the new results we have gathered through this work, we see whether we can separate between potential long-range transport and local pollution sources. There are a variety of different aspects which needed to be considered here when we want to discriminate between remote and local sources. Firstly, we expect, and we also acknowledge, that the population in the northern regions in the Arctic are low, and we are dealing with a sparsely populated region and generally across the Arctic, so that we can expect that the minor contribution of local sources is the case for the Arctic. Isolated communities and so on, on the other hand, they require very sophisticated and very well life-supporting infrastructures for every unit, if they are not necessarily available in it, which are not available in the grid, which has been normally the case in more mid-latitude regions. So that means that the infrastructure which are supporting the communities, they need to be repeated. They need to be available for small communities, which can actually contribute to local contamination. Currently, also triggered to climate change, we see that industrial activities are on the rise in the Arctic. This can contribute to an increased potential of local contamination sources, specifically when it comes to exploitation of different resources in the Arctic, like oil and gas and minerals. Mining is a main aspect there as well. So we see that there are increased numbers of mining in all Arctic countries, which again can contribute to to local contamination, but also potentially some conflict issues with the local populations as well. Military installations and exercises are already identified and also considered as potential contamination sources when it comes to the Arctic environment. And we also see that due to the changes in the geopolitical situation, we can expect more military activities also in the northern regions with the potential for local pollution in marine and terrestrial environments. Of course, the other thing is also potentially due to the loss of the summer sea ice, for example, shipping activities and tourism, they're reaching also central Arctic areas which have not been accessible for them in earlier years, so, which also again can have a potential for pollution. Of course, all these things are directly or indirectly potentially associated to climate change, and the future potential scenarios needs to be evaluated carefully. A part of our work has been also summarized when it comes to climate change and future work in a recently published review paper by Derek Muir and co-authors, which you could look into in Environmental Science Advances, is published just a few months ago. Local pollution, there's some evidence and there have been some earlier studies and monitoring activities going on local pollutions, for example, here associated with persistent organic pollutants, with polychlorinated biphenyls. Just roughly 13 years ago, there have been a study by supported by the governor of Svalbard to look into potential local contamination of polychlorinated biphenyls from industrial locations and abandoned sites on Spitsbergen and Svalbard in generally. There have been identified something like 200 different potential sources locally, and they have been also taken care of, so that old defect equipment or waste dumps have been cleaned and sanitized and reported there. We saw also in the studies which have been followed up on that we had, and for some of the locations, hotspots with elevated concentration, like here in the sediments, for example, close to a local industrial site. Mainly mining activities at that time have been identified as significant contamination sources. They have been cleaned up, and they are now, the levels of PCBs had been drastically declined when it comes to compared to the concentrations which have been reported during this study 10 years ago. I mentioned already there have been some summaries also from AMAP, the Arctic Monitoring Assessment Program, published in recent years, two relevant reports on chemicals of emerging concern and influence on climate, but also a summary on recently emerging chemicals of emerging Arctic concern, which is about to be hopefully be updated soon in 2016, just roughly 10 years ago. In this study here, we have been reported something like 16 new chemical groups identified as chemicals of emerging concern. And when we're dealing and talking about chemicals of emerging concern, we are talking about substances which have only been sparsely investigated. We have no data potentially on direct effects or distribution pathways, source characterizations, and so on. There's a large need for closing these gaps as well. So there are several research groups which are dealing with that. This information which is provided here, this actually also supported by a series of case studies, like for example this one. There's been a PhD study conducted in collaboration with the Norwegian Institute for Air Research and our university, where we looked in high volume air samples from Ny-Ålesund, the international research station north of in Spitsbergen, where their monitoring program is ongoing there for the past 25 years on a variety of priority chemicals, including metals and persistent organic pollutants. In this study, which have been utilized new analytical methods, they could identify roughly 700 signals in the particle phase and 1,200 signals in the gas phase of this 3,000 cubic meter air samples, which have not been identified and not been clarified as potential contaminants in the Arctic. This is just indicating and showing us that there are a lot of unknowns yet, which needs to be identified and looked at. even in air samples which are today considered as one of the cleanest air in the world in the northern environments. So there's still a lot of work to do for our young scientists, including, yes. So when we started this work, to characterize local pollution in the Arctic and try to find signals which will enable us to discriminate between local sources and long-range transport, we had several different aspects to be covered. So we looked into the potential characterization of local sources and the different regions and looked into literature information about that. We have identified compound-specific indications for the significance of local sources and also impacts on the local environments. There have also been some information, and this will be provided in this special issue, which is just about to come out now, on how our Arctic monitoring data can be used also to identify long-range environmental transport and see whether we can find some information on local sources there as well. And we, for example, also can we look into chemical specific and site specific indications where you'll see is there predominantly impact from a local or from a distant source, which are contributing to a specific exposure situation or concentration in Arctic animals or in environments in general. Usually, we can expect when we're dealing with the local contamination and signal which are manifested as a halo. That means in a certain distance from a populated area, we can see potentially elevated concentrations of certain contaminants which are locally emitted in organisms or environmental compartments. Important issues are also potentially here for our motivation to work with this, to look into to characterize potential exposure situation when it comes to the indigenous and local communities in the different Arctic environments and areas. This will hopefully also can be used as a kind of platform for regulation locally or regionally. Just a few examples here. In municipal waste are identified as potential hot or important local sources. There are landfills, important and solid waste, mostly uncontrolled domestic sources, but also military locations or abandoned military sites, which are identified as potential local sources. There are fossil fuel burning, which is considered as a very significant potential contamination source, specifically for local environments and for potential human exposure, because fossil fuels are also utilized for power production, heating, transportation. There are the potential sources which needs to be considered here. Here, for example, also increased activities have been established. Oil and gas exploitation is a potential local contamination source, specifically in the eastern Arctic waters. In the Barents Sea, identified a lot of new installations which will set up also after it's easier to approach areas which haven't been available before for economical exploitation. They have also other activities when it comes to oil and gas exploration. In the Western Arctic, we're looking into potential contamination effects of land-based oil and gas, for example, from the oil sands. But we have a similar situation in the Eastern Arctic and from the terrestrial areas and the land-based areas when we see emissions from oil and gas exploitation in the Pechora area, in Chukchi area, and Nenets, and so on in the Russian areas, where we can expect we having emissions from PAHs to the operations, industrial chemicals, flame retardants, volatiles, and so on. Transportation is a main source of potential emissions, and the numbers are increasing because the population and the potential industrial activities in the north are expanding, and they need to be supported, and the infrastructure needs to be kept alive. So the shipping is an important vehicle, a way or route to transport goods and support for different remote locations. We're having a variety of other locations, like, for example, here, domestic challenges in the north is that we're having usually economical restrictions there. There are the infrastructure, for example, for water supply systems, waste handling, sewage treatment are usually up to date or not even present. We're having issues with drinking water supply systems due to potential loss of permafrost. Infrastructures are destroyed. Basically, for example, sewage facilities are lacking in many locations, specifically small ones. We have a storage of waste and sewage, which is not regulated or organized properly in many locations, regardless where in the Arctic. We're having obviously some changes or issues associated with erosion, loss of infrastructure, damages of infrastructures, extreme weather events, which are also affecting potential, can contribute to elevated emissions and contamination. This has been also in detail been elucidated in the paper by Derek Muir et al., which I'm very much strongly recommend for you to read. We're having most of this effects, specifically when it comes to erosion, infrastructure damages, they are affiliated or associated with cryosphere loss. So it's a potential climate component implemented there as well. And then indirectly, of course, demographics and accessibility of regions they are, of course, directly influencing industrial new establishment, tourism activities expanding, transportation activities. Here are some signals, for example, from local contamination. We're having here, for example, in Longyearbyen, we're having a coal-fired power plant, which has been recently switched off. It is not active anymore, but there have been a study in 2020, I think, where it was in the course of a PhD project, where they've shown that this has been a relatively the significant emission source for polycyclic aromatic hydrocarbons. We see here the profiles from the emissions at that time from the Longyearbyen power plant with relatively high concentrations, mainly associated with the gas phase. So the smaller ring systems, 2 to 4 ring systems predominantly emitted there, whereas the particle phase has been very well retained through electrostatic filter systems, which has established in the system. This unit is not working anymore. We've done a similar study on the diesel generators. There has been established recently there for heating and power production. And it showed that the concentration from the gas phase have been increasing for the pH concentration compared to the levels we identified a few years earlier for emissions from the power plant. Other hydrocarbons, like here the VOCs, BTX chemicals, have been emitted here. This is a study from a few years ago by Reimann et al., which showed the emissions from volatile organics, for example, and the seasonality and the distribution of that. It is also shown that, for example, by regulation, you can strongly reduce it, because they have been done after this study has been published. There were a reduction. There have been new regulations for the transfer from 2-stroke to 4-stroke engines, and then the concentrations went down relatively quickly. Sewage treatment plants is a main challenge. Usually they are stored they are rather directly emitted, directly released into the adjacent water phase, or stored in ponds and then kept there for generations or so. And now with the loss of permafrost, we can expect much more mobility of potential contamination, especially for those which are directly released into the water phase or into the coastal waters, or stored in permafrost cover in ponds, which are usually isolated through permafrost. Loss of permafrost has definitely consequences for that as well. PFAS, perfluorinated chemicals, needs to be covered. Perfluorinated chemicals have been distinct local sources. In this case, Arctic airports, for example, and airfields, where there are usually been done firefighting training activities, and PFAS have been shown to be main ingredients of firefighting foams. And this has been also supported, for example, by a study here in Longyearbyen. We see that the concentration of the soil and the meltwater runoff from the firefighting training site, both in Ny-Ålesund and in Longyearbyen, showed to be considerably increased, up to 1,200 nanogram per liter, or nanogram per gram dry weight in the soils. And this is something like about half of what we have seen in larger airports, for example, in Oslo, in the main airport in Norway. Now, let's just continue and conclude that local sources are important, and we have identified this, and we also confirmed that in our report. The variety of local sources having different type of signatures and profiles, which needs to be identified and looked into in more detail. Legacy POPs are introduced also by local sources, but we can expect that for this persistent organics, long-range transport, either through atmosphere or in oceans, is the dominating source. But how it looks for new emerging contaminants, there are some indications that they are actually much more significant as local sources, but this needs to be also looked into in more detail in dedicated research studies. There are the research knowledge gaps, which I want to highlight here as well. We see that there are lacks for the chemicals of emerging concern when it comes to spatial trend and fate studies. That is a main challenge, especially for those which are actually identified in mid-latitude regions as readily transformable, but showed this tendency for persistence and environmental stability under the cold Arctic conditions. What is the situation there? And maybe the term persistence or environmental stability needs to be revisited to cover also this type of chemicals. Comprehensive information and source apportionment is an important issue, specifically identifying the significant important sources for regulative purposes. So we need to look into the transformation processes as well. Can we identify transformation processes which have even more having more environmental stable, or they are more toxic substances? There are still some information lacking there when it comes to transformation and environmental condition. The toxicology and the presence of the substances needs to be established to make good recommendations for regulation. So, and for that, I thank you for your attention, and with our friend here from the north, and then I give the word to Pernilla Carlsson.
Thank you very much for inviting me and let me talk today. I will have 2 examples to show you about local pollution, where one is on PCBs, the one Roland mentioned in his presentation, and then one on a cleanup and a remediation of a coal mining site on Svalbard. And for those of you who doesn't know me, I've been working in the Arctic for a few decades with a PhD from UNES, together with the Norwegian Institute for Air Research and Tromsø University. I've been also working in Iceland and teaching in Høgskoleseter Vestfirði, and I've been ice diving for Norwegian Polar Institute, and I'm today diving for Norwegian Institute for Water Research. So there's usually a bit of underwater pictures in my presentations, as you can see here. And I've also been involved in several of the last AMAP reports, and I'm now chapter lead for the other media reporting to Stockholm Convention. And my research interests are mainly in water and sampling setup, and a lot on local sources and spreading, both in the Arctic and also in the subarctic, where I'm currently living. Here is the Arctic as we are very often seeing it. We're seeing it, Arctic and the world. Arctic is pristine, very little PCB usage, and so on. But there is differences in the Arctic as well. So when we're working with local pollution, we need to have an understanding of what is a remote and a pristine area. And when you look on the Arctic and when you look on Svalbard, that's my main study area, you would like to think that this is an area with that is very pristine and there's no pollution. We know that that's not the case, and as Roland has showed several examples. And just to give you some idea of the distances we're talking here, we have a Zeppelin station that some of you might know for air monitoring up in Ny-Ålesund. That is a remote monitoring station. And just 110 kilometers further south, we have Barentsburg, who I will be talking about, which is a Russian mining settlement. And in the same distance, we have Longyearbyen. And from Longyearbyen to Pyramiden, Pyramiden is an old abandoned Russian mining site. And Longyearbyen is the main city and main settlement of Svalbard as of today, with 2,500 inhabitants. And between Longyearbyen and Pyramiden, it's about 50 kilometers. So just to give you an idea of the scale we're operating on here. This is a picture of Barentsburg, where the coal mining is the coal mining, and there is and that's where the electricity come from the coal power plant. And as Roland said, some years ago, 13 years ago from the report, and soon to be 20 years ago from the first investigations that started the whole cleanup, we know that there was extensive usage of PCBs in Barentsburg, and we know that there was the same case in most likely in Pyramiden. And there were investigations made by Aquaplan Niva, routine investigations on the sediment outside Pyramiden for PCBs, and some investigations suddenly showed elevated concentrations. And the reason for this, figured out later, was most likely a big flooding of Pyramiden settlement that drained the land area for a lot of soil and particles that contained a lot of PCBs, and that came out to the ocean. And there was no reason for having very high levels outside Pyramiden and not outside Longyearbyen, so to say, because the atmospheric contribution is the same, roughly speaking. And this all led to that we needed to clean up Svalbard from PCBs. We understood that there was local sources, and there was a joint forces between the government of Svalbard, the Trøstak Kugel, who is in charge of the Russian settlements and running the settlements, and then the Norwegian agencies for environment and for water, and Aquaplan Niva as a scientific partner, as well as UNES. So people went into these areas and mapped and removed and sampled, of course, the different bits and pieces, everything from paintings on the walls of the houses to soil to water, to see where are the sources, removed sources, and took care of it in an appropriate way. So this is the area in Pyramiden. We have about 430 kilogram PCBs per square kilometer. And I think that this number is comparable to what the largest Arctic rivers has been estimated to put out to deliver to Arctic per year, roughly about 400 kilo total delivery. So that says something about which scale of amount we're operating on here. Barentsburg also had a lot of PCBs in the area, and there were waste identified with PCBs that were removed, and some were marked for later removal. And to compare this, Barentsburg had about 300 kilograms PCBs per square kilometer, and the same as the investigations done in Longyearbyen showed around 3 kilos per square kilometer. And that meant that we were very close to the background levels in Longyearbyen. And the follow-up, or the long-term perspective, is that thanks to banning the PCBs, we also see the decrease over time. We got the reason for removing direct sources, and when we look on the long-term long-range transport, we see that PCBs in polar fox and in Arctic fox and polar bears, it's decreasing over time. So these are figures from the last AMAP report. And the same trend is shown for Arctic char from Lake Ellesjøen in Bjørnøya, which is an island between Svalbard and the mainland of Norway. So thanks to the ban soon 40, 50 years ago, we're reducing the concentrations of POPs. My second example on local pollution is also a cleanup example on the old mining settlement Svea. This presentation is based on slides from Kristine Bondo Pedersen and Anita Evenset from Aquaplan Niva. Aquaplan Niva, that I work closely with, they were in charge of the environmental pollution assessment for this cleanup. So the Svea settlement, it's further south from Longyearbyen, some 50 kilometers, so still quite close to Longyearbyen. It's been coal mining activities for about 100 years, but in 2016 the mining paused for about 3 years. And the Norwegian government had decided to stop all the Norwegian mining activities on Spitsbergen. And then the goal became to decommission Svea, to remove all the infrastructure except what is protected by cultural heritage, and also to restore the landscape to the natural processes, could adapt this back to pure nature, so to say. It was also, of course, said that pollution that pose an unacceptable environmental risk should be removed. So Aquaplan Niva went in to do a lot of sampling to assess which areas that could be, where soil could be reused and what needed to be removed and transported for destruction. The main pollutants here they focused on, it was oil related, like alphatics and BTEX, PHs, PCBs, of course, metals, PFAS, and brominated flame retardants, PBDEs mainly. The main areas of pollution concern, so to say, it's a coal mine, the workshop area, town itself, airport, there were landfills, shooting range, oil tanks, and sewage. And first of all, they had to think a bit about what is background, because when you look on soil pollution on the Norwegian mainland, we have a system of 1 to 5 levels, where 1 is background and 5 is very, very high concentrations, and a range in between. And that's used for whether you can reuse soil, for example, or whether you need to deposit as toxic waste. But this system is made for the mainland of Norway, and it's very difficult to apply it to Svalbard, because Svalbard has a different geology. And as an example is that the background levels of arsine is a level 3, which would be moderate risks, but it's on Svalbard, it's a background level due to the geology. And similar cases are there, of course, for PHs and some metals and benzene, because coal is a natural element in the landscape. So these guidelines, they had to be used a bit with caution. But then overall, they found metal concentrations very low in all the areas, and it was a low risk for acid mine drainage. There were some areas with small, medium-sized oil pollution, and most of them were old, containing long-chain hydrocarbons that were considered to be stable and pose a fairly low environmental risk. There was also a lot of waste that was buried in a few areas. There was one area with a major oil contamination, some areas with PFAS, and one with brominated flame retardants. And it's those 3 that I will show some examples on how they were handled. So the oil pollution, it came from diesel leakage in 1978, and that oil remained stabilized behind a vault in the tank area. And the polluted soil was then stabilized and covered by clean soil. And this area could also be used for disposal for lightly oil polluted soils from other areas of Svea, where they wanted to remove the the oil in that soil to due to the landscaping shaping considerations. So this picture, they've used the picture I showed you with the colorful range on the previous slides. So green and blue are, so to say, background or just elevated above background, and red, orange is high levels. It's quite limited area. There was a fire drill area where it obviously has been used firefighting foam containing PFAS, and there were found moderate levels of PFAS in the soil. There were some soil that was considered to be contaminated, and that soil was removed and transported to the Norwegian mainland for as toxic waste and taken care of there. And then soil with low levels of PFAS, they were acceptable levels. They were covered with clean soil on the site to shape the landscape. The brominated flame retardants, they were mainly they were found in an area used for intermediate storage of vehicles and machines, etc. There was high levels in several of those soil samples, but there was at least low levels in the water. And again, here any contaminated soil was removed and shipped to the Norwegian mainland for taken care of. The conclusions, there's a lot more you can say about this whole process and restoration. But it's a pioneer project, and it was a very dedicated and interdisciplinary project team, both with the research institutes and Store Norske, who is the company owning the governmental company owning Svea, running the coal mining town. And the environmental authorities were also collaborating here and with input and everything. And this is actually a project that was finished ahead of schedule, and it costed way less than the first estimate. So that was also a very nice outcome of the whole project. And the next project, it's for this. It's Mine 7 that is was closed earlier in 2025. That is the coal mining mine that was, as Roland said, where the coal comes from to the coal station in Longyearbyen. And finally, here are some pictures on the landscape in Svea before and after. So as you can see here, you have houses and a small settlement. And today it's a river delta, or a river running out towards the ocean. Here's another project picture where you have the whole town, and that is shaped to be kind of a delta, something where the river drains out and into the ocean again. And here's from another angle as well, so you can see where the roads are removed, and the coastline is shaped new again, so to say. So the local pollution is a way better known issue today than it used to be. We have some remediation techniques to deal with this. And we know when we see that the ban of the POPs is one of the most effective measurements to decrease POP concentrations all over. So thank you very much. That was it from me.